All right, so what we're going to talk about today is we're going to talk about how the function of a quadratic equation in vertex form moves about the graph. We see y equals x squared, that's our parent function, and we're going to look at how does it move. Well, based on our Desmos activity of what we did the other day, you should look and see when it says x squared plus k, you should figure out what does the k value do. Well, stop and think about what x plus 3 does, what the plus 3 does in a linear function. In a linear function, we saw that that plus 3 caused that line to shift up or down. Guess what k does? K causes a vertical shift. Okay, so the k value causes a vertical shift. Right? When we look at x minus h, it's also going to cause a vertical shift, and I'm just going to put quotes here because I don't want to write this a ton of times today. Make sure you put causes a horizontal shift. And the trick here is if it's x minus, it actually shifts to the right. Okay? So make note of that. Then what we look at is, what about x plus h? Well, x plus h causes a horizontal shift left. Again, do not put quotes. Make sure you write causes a horizontal shift left. Okay? Now when we get into the bottom two here, this minus sign right here, what this is indicating is that my parabola opens down, right? The negative is going to cause that parabola to flip. That's what the negative value does. I'm convinced that the negative here, that's what they're insinuating with that, because down at the bottom, the a value here, the a value is talking about a stretch. And let me go back here and make sure we note that. The quote-unquote a causes a stretch. And I'm going to give you an example of what a stretch is like. A stretch is a really skinny graph. Okay, the rubber band technique, if you were in class, you talk about the rubber band. It stretches. It causes a stretch or a shrink, which is going to be a really wide parabola. So it's overemphasizing what's going on with the stretch and shrink. So when we get down to the bottom here, when we talk about the exit ticket down here at the bottom, if this thing will cooperate, right here, what is happening? Well, 5 is my a value. So this is going to cause a stretch of 5 or by 5, either or. When you look at x minus 5, this is going to be a horizontal. That's bad. Let's see if I can fix that. Shift. Where? Horizontal shift, or we could just say shift if it's minus right 5. Well, if that's the case, you should be able to answer this one, x plus 5 squared. And then the last one, this is a vertical shift up 5. All right, so that's our causes there. Now when we got into the set, we compared f of x, and this was done in class pretty easy. We compared f of x to g of x. F of x was y equals x squared. That is this function right here on a graph. Well, notice the vertex is in the middle, and we have our 149 pattern. We notice that it's meeting in the middle. Since we notice it's meeting in the middle, I'm going to apply that same philosophy over here, but I got to find out where the middle is. And you should look, it's 0, 7. Here's my vertex. All right, so 0 and negative 7. So 0 and negative 7 is my vertex. Now, I'm going to pick 1 or 2 points on either side of my parabola and know what the pattern is going. Is the pattern still 149? Because if it is, that's going to be normal, like y equals x squared. So 1 and negative 6. 1 and negative 6. 2 and negative 3. That's got to be 2 and negative 3, not 1 and negative 3. So I got to go to 2 and negative 3. And if I see, yes, it has a normal pattern. And I go over 1, up 1. I go over 2, up 4. Over 3, up 9. So that 1, 4, 9 is still a normal pattern. And that's how I can tell my parabola didn't stretch or shrink at all. And so what has happened to the graph of g of x? The graph, what has happened to the graph of g of x is that it has shifted how? G of x has shifted, come on, end of the day here. Down 7 units. That's what happened, all right? So what you need to do is you need to go through and you need to identify the vertex in 12, 13, and 14, all right? And then just simply state what has happened. How do you compare? So find the vertex, plot the points, graph, okay? Graph, and then ask yourself, what has happened? Did it shift right or left? Did it shift up or down? Did it do both? What has happened here? And then come back, and when you come back, you'll go ahead and create the equation. Well, how do I create the equation of g of x? That's pretty simple. G of x is going to be equal to what happened to it. It shifted down 7 units. If all it did was shift down 7 units, a didn't change, so a is still 1. I don't put a 1 in front of anything. We don't. So a is there. It didn't shift right or left, so that's going to be an x. There's no shifting. I probably wouldn't even write the parentheses. So there's x squared, and it shifted down 7 units. So g of x is equal to x squared minus 7. There is your equation for that particular set of data. It's that simple. Try and write your equations for your other 4 as well. All right, so that's it in a nutshell.